In this video, we'll talk about the different aspects of the scientific method. Here's an illustration going over the scientific method. We start with observations about the world and generating a research question. From that, we create a hypothesis and a specific prediction resulting from that hypothesis. Then you test your prediction using an experiment. Resulting from that experiment, the data will indicate if your hypothesis is supported or refuted. Then you use that to update your original hypothesis, which can be used to make future predictions. So we'll go ahead and break down these steps a little more. The first step is to observe something. From the observations you make, you can generate a question. There aren't any limitations on this, and you can use any source of knowledge to generate questions, from personal experience to authority to rationalism to prior research. Here we have an example with a research question: why does my car smell so bad? Two things you'll need to consider when generating a research question is how interesting and how feasible your question is. You really want your question to address a gap in the literature. It also helps when the answer has important practical implications. You also want your question to be feasible. There will always be limitations in research, from time to money to lab equipment to technical skills. You want to ensure that you'll be able to be well equipped to successfully test and answer your question. Step 2. Form a tentative answer or explanation of your question. Formulate a hypothesis and make sure that this is informed by investigating previous research. It's important to dissociate a theory from a hypothesis. A theory is a coherent explanation or interpretation of one or more phenomena. They explain the variables, structures, functions, or organizing principles that have not been observed directly. Theories are well tested and well substantiated. A hypothesis, on the other hand, is a specific prediction about a new phenomenon that should be observed if a particular theory is accurate. Testing multiple hypotheses often contribute to the development of a theory. Okay, going back to our example, after observing that my car smells pretty nasty, I form a hypothesis that my car smells bad because no one cleaned out the fast food wrappers. Keep in mind that a good hypothesis must be testable and falsifiable. Hypotheses can either be supported or refuted. Hypotheses must also be informed and logical. They aren't just random guesses. Step 3. Take your hypothesis and generate a testable prediction. This will enable you to figure out whether your hypothesis is true. You can take these predictions to see what will happen under certain conditions. In our example, we can specify a testable prediction. Our prediction is that if you take out the fast food wrappers, the car won't smell anymore. Step 4. Evaluate your prediction by making systematic, planned observations. You can design and perform an experiment. We can manipulate a variable and collect some data. In a future video, we'll be going over this in more depth. But back to our example, we can take out the fast food wrappers and then re-smell the car. Step 5. Take the data or observations we collected and make a decision on whether our hypothesis is supported or refuted. We can then use that conclusion to refine our original hypothesis. In our example, if the car smells better, the fast food wrappers was the cause, and our hypothesis is supported. If, however, the car smells the same, then there was another cause of the smell, and our hypothesis was rejected. And in a final step for the scientific method, we use the results of many experiments to help formulate a theory. Like before, a theory is a framework for understanding some aspect of the world. Say we ran several experiments on the smelliness of the car, we can develop a theory, or our theory, of putrid automobiles. Theories help guide future research and generate more and more research questions. So those are the steps of the scientific method. Make sure to read chapters 1 and 2 of the textbook and be able to think about the following things. What are the steps to the scientific method? What are the 2 things that go into generating a quality research question? What's the difference between a theory and a hypothesis? And be able to think of a different example and be able to describe the different steps of the scientific method. Okay, that's it. See you guys next time.